Okay, so today we want to talk about hyperbolas, the last of our conic sections that we're going to work with. You should see a lot of connections between ellipses, right? A lot of same look to them. There's just going to be some subtle differences. So one thing with these is when we have them, they're going to look one of two ways. You're going to have a horizontal orientation or you're going to have a vertical. So if it's horizontal, it's going to have two branches, one to the left and one to the right. Okay, they're always both going to have two branches. It's not like a parabola where you have to decide, is it open right or is it open left. Hyperbolas are always going to have two different branches here. Okay, so it's going to go to the left and right. Now the standard form for that equation is going to be x minus h squared over a squared, should look familiar, minus y minus k squared over b squared equals 1. Okay, so for the equations today, since we just wrapped up ellipses and how to shift them, we're just going to go ahead and I'm going to give you the full thing where they're already shifted. But if it's centered at the origin, h and k would just be 0, and it would make it a little bit easier to do. They're really not that bad. If you just know you're going to move side to side and up and down to find different points and things, you'll be good. So with this one, the center would be at the point HK, and then the transverse axis, that's a fancy name for the segment that connects the two vertices. Okay, so it's going to be horizontal, and it's going to have a length of 2a. I guess the absolute value of 2a to be most correct. And again, so that would be if you had your two vertices here and here, the transverse axis would be that segment that runs between those two vertices. The length would be 2 times a. So a is going to be the horizontal distance from the center to each vertex. Okay, just like we saw with ellipses, right? So a squared is going to be the number underneath the x minus h squared. Again, we're going to see that a goes with the x's, just like we did before. So our vertices, since we're starting at hk, it's going to be h plus a comma k and h minus a comma k. So again, a units right, a units left from the center. B, now with this, with ellipses, it always mattered which denominator was bigger, right? The bigger one, if the bigger number was under the x squared, it told you it was more wide type of ellipse. If it was underneath the y squared, it told you it was higher. Not the case with hyperbolas. Hyperbolas, it matters which one's positive, right? So here, because x minus h squared over a squared was first and was positive, and then we subtracted the other one, that tells us we're going to go side to side with our two branches. So for b in this case, we don't use it a bunch, but it is actually the distance to the co-vertices. And there's what's called a conjugate axis. In this case, it would be vertical, and it would have a length of 2b. Again, we don't really use b for that a whole lot. It's not really what we do. But if you're curious, and then sometimes, maybe I'll try to show you one where sometimes they'll draw a rectangle to help you get the asymptotes, and you use b in that also. Now, what's different is because we have a hyperbola, we actually have two asymptotes that kind of help us give us that shape. And the equations for those, well, they're both going to have a slope of plus or minus b over a. And they pass through the center. Right, so it ends up the equations look kind of, because the center shifted, looked a little bit wonky. They're going to be x, that's going to be y minus k is plus or minus b over a x minus h. So really it's just a line through the center with a slope of b over a or a slope of negative b over a. So if you have to write the equation, that is going to be the format though. Notice it's shifted h units to the right and k units up. The last thing we want to do is figure out how to find the focal points or the foci. So c squared in this case is going to be a squared plus b squared. Remember we talked about that our focal points will be outside of the vertices, right? It'll still open around the focus points. So then in this case, since it's opening side to side, the foci will be at h plus c, comma k, and h minus c, comma k. So you see there's a lot of stuff going on here, right? A lot of different numbers and things. So let's go ahead and maybe jump, before we fill out the thing for the vertical, let's just go ahead and jump to the back and do example 1. Go ahead and write that up here. Okay, so here for example, we have x minus 3 squared over 16 minus y plus 3 squared over 9. Okay, so since the x squared part comes first, it's going to have side-to-side pieces. And that's the way you have to tell whichever one's positive. That's the way that's going to work. Okay, so now the center, we can see it's been shifted. So the center will be at the point 3, negative 3. So go ahead and plot that there. And that is a very important point. It's how we're going to do our asymptotes. It's how we're going to move to find our vertices and our foci points. Okay, so now vertices, I'm going to look at, it doesn't matter that 16 is bigger than 9. It is, but it doesn't matter. It's because it's first, because it's the positive one. That's going to give us that a is equal to 4. So for our vertices, we're going to go 4 to the left, and we're going to go 4 to the right. You can label those v sub 1 and v sub 2. So that would give us 7, negative 3, and negative 1, negative 3. Does that work? Does that work okay? Okay. Now for the asymptotes, for that we're going to need to know what b is, and b is going to be 3. So I know that the asymptote will have a slope of, well, there's 2 of them, plus or minus 3/4. It's always going to be b over a. I always think of it, it's always, we know slope, we always tend to think of that as rise over run, right? Up and down, over side to side. So to me it makes sense to think of it as b over a all the time, because b is the number we associate with y, which is up and down, and a is the number we associate with x, which is side to side. So now that's the slope. To graph those, you just start from the center and use the slope to find another point. So if it's 3/4, we would go up 3 over 4. So one of our asymptotes would look like this. Oh, I lost mine. Okay, there's that. And then, so from here, then we'll go down 3 over 4. Again, I'm just going from the center and I'm using the 2 slopes. So we had 3/4 and then negative 3/4. So there's the other asymptote. Now to write those equations, if they were centered at the origin, it would just be y equals 3/4 x, and y equals 3/4 y. But because it's shifted, we're going to, instead of saying just y, we're going to say y plus 3. Instead of saying just x, we're going to say x minus 3. So the equations of the asymptotes would be y plus 3 equals plus or minus 3/4 x minus 3. So just write it in point slope. It's super easy to write that way. You don't have to spend a lot of time thinking about it, right? So again, if it was the center, it would be y equals plus or minus b over a times x. We're just replacing x with x minus 3. We're replacing y with y plus 3. That's the way you shift it. Right, so the point that we're starting from is 3, -3, and then we're using those two slopes. And the last thing we want to do is do our foci, and we were told before that a squared plus b squared equals c squared. So 16 plus 9 is c squared, so c would be plus or minus 5. So that means from the center we're going to go 5 to the right to find a focal point, 5 to the left to find a focal point. So that would be 8, -3, and -2, -3. So now at this point, you can just kind of sketch your hyperbola in here. You shouldn't cross over the asymptotes because, you know, they're asymptotes, but that's what it will look like there. So again, you can think of this as an ellipse where you pull the focal points outside of the vertex. Kind of turns it inside out, maybe. Way to think about that. Okay, the other way that we're going to see hyperbolas is they're going to have their two branches be vertical, one up and one down. So now, as we look at that, the equation's going to look the same. The difference being is now the y minus k squared over b squared is positive, and we're subtracting the x minus h squared over a squared. So again, one difference that's pretty significant between ellipses and hyperbolas is ellipses are kind of driven by whatever denominator is bigger, where hyperbolas are driven by whichever thing comes first, whichever term comes first. And that can be a little confusing if you're not careful there. Okay, so with this then, this is our standard form. Okay, so our center, as you would expect, I hope, will be at HK still. Okay. Now, A is still going to be our side-to-side number, but in this case, A will determine covertices and the conjugate axis, but again, I spelled conjugate wrong. And the conjugate axis, but we really don't use that much. Like, that's not something that we're going to be really focused on. We'll talk about the transverse axis, vertices. B, because it's with the y squared, will determine the vertices and the transverse axis. Remember, a transverse axis goes from vertex to vertex, so it'll be up and down here. So in this case, our vertices, we're going to start at our center. We'll go up b units, we'll go down b units. So it's going to be h, k plus b, and then h, k minus b. The transverse axis will be vertical, and its length will be 2b. Right? Whatever b was, it'll be twice that. Now our asymptotes. You can't, I have seen textbooks where they'll switch where I have a squared and b squared. I don't, mostly because I like to always have the same equation for my asymptotes. I always want it to be plus or minus b over a is the slope. I know b is the thing that's always hanging out with the y. A is always hanging out with the x. So our asymptotes here, if our center's at hk, will be y minus k equals plus or minus b over a. X minus h would be the equation, which is a little bit strange. What I would recommend you do to graph them is start from the center, and then we use slopes of plus or minus b over a to find a second point on each asymptote, and then we just go ahead and draw it, just like we saw in the last example. Let's see, again, c squared is going to be a squared plus b squared. And I always like to think, because we need the focal points to be farther out than anything else, so that's why we're always adding it to get a bigger number there. And in this case, our foci would be at h, k plus c, and then h, k minus c is how we would do that. Did I forget anything there? I think that was all that we had to fill up. Does that make sense, though, how it's very connected to what we just did? Are the same ideas going on there? Good.